Hello everyone. So far we have talked about matter and the classification of matter according to physical property, or we can say physical classification of matter. And in another classification we have seen about the chemical classification of matter. In case of physical classification, we have seen solid, liquid, and gas phases, while in chemical classification we have seen pure and mixture. In case of mixture is further classified into homogeneous mixture and heterogeneous mixture. While in the case of pure pure matter is further classified into elements and compounds, right? So we have seen that the matter we have seen the classification of matter. Now we will deal with the measurement of matter. Matter could be measured either in the form of qualitative, or it could be measured in quantitative, right? So first of all, the measurement of matter is measurement is classified according to physical property or chemical property. So what are the physical property? Physical properties are those properties which can be seen or which can be observed through our sense organ. Some of the physical properties are melting point, boiling point, order, and color. As you can see from the example, the color itself can be observed through our eyes, and we can see if any matter is of which color. If we see a red color pen, then we can see a pen is of red color, right? If we Similarly, in case of order, if we if we if we order any if we order any chemical, then the different order of the different chemical is different, right? So let us take example of H2S gas. H2 gas is a pungent ordered gas, while if we snore or snore any sulfuric acid fume, then the spume is ordered different, right? So we can say the physical property could be observed through our sense organ, while in case of chemical property requires the disturbance in the chemical composition of the matter. For example, combustibility. Here the matter is burned by providing it oxygen. The matter is burned, and the respective product shows the chemical property of the element. Similarly, the reactivity with acid and base defines the chemical property of any matter. So basically the chemical property requires the changes in the composition of the matter, while in case of physical property it doesn't require any changes in chemical structure or chemical composition of the matter, right? So now we will talk about measurement of physical measurement of matter. Now we have to deal with the measurement of physical property of matter. So if we want to measure any matter's property, it can be either in the form of quality or in the form of quantity. Let's take an example of quality and quantity. Mm, let's say a boy is a good boy, right? Let's say boy is a good boy. So good is his quality, but if I say the boy is very good, if we rate the goodness in 1 to 10, then if I am judging a book sorry I am judging a boy, or I am giving him a number like he is a 8 8 out of 10 good. So I am judging his quantity of goodness, right? So goodness is a sorry let me write here. Good. Good, his good is his quality. Quality. Quality could be he could be good, he could be bad, he could be very good, he could be very bad. So the goodness is its his quality. But if I'm rating his goodness, like he is 50% good, or I would say he is 60% good, then the number which showing his quality, the number which showing his quality is known as quantity. So if I am rating the goodness of the boy, if I am saying he is 50 or 60% good, means this shows the quantity of goodness present in him, right? So similarly, we have to deal with quantity in term we have to deal with quantity of matter. Quantity of matter means measurement of physical property. Quantity is a physical property, right? So we can observe the physical property. So if we say quantity, so quantity like 1 2 3 4 5 6 7 8, these are the quantities. If I'm saying if I'm saying the length of a pencil is 10 centimeter, then I'm saying his quantity, right? So quantity is observable, right? But the chemical property is not observable. We required a chemical changes. It required a chemical changes in order to get the composition of the matter. So I'm telling about physical property, physical measurement of physical property. Here measurement of physical property, right? So for example, the physical property is measured quantitative by this following two main thing. The first one is the numeric digit followed by unit of the measurement. So the numeric digit, here I have written three examples. Here 18 is a digit. We know 1 2 3 4 5 6 are digits, and it is followed by unit. Like here I am taking meter, and here I have taken 1 is a numeric digit, and followed by unit, that is liter, 1 liter. We can, so what I want to tell you is the physical quantity, the quality physical quantity is measurable. So we have to measure the physical quantity, right? So here I have another example, 15 meter cube. As we know, the meter cube is the representation of volume of volume of a container. So 15 meter cube means 15 is a numeric digit and meter cube is a volume. So what I want to say is the measurement of any physical property has two main thing. That is, first one is a numeric digit and it is followed by unit. So initially earlier two different system of measurement, that is English system and another thing is metric system were used earlier. So in metric system, which originated in France in late 18th century, was more convenient as it was based on the decimal system. But English system was originated in, as we say, when I say English system, English means British system. But but the metric system was originated in France. Okay. The ASI system, or I would say system of international, was established by 11th General Conference on Weight and Measures. The CGPM is an intergovernment treaty organization created by a diplomatic treaty known as Meter Convention, which was signed in Paris in 1875. So, the SI system or System of International has 7 base units, and they are: first one is a kilogram. So here we can say we have to deal with the mass. Similarly, meter, as we know, we use meter unit to measure the distance. And similarly, here time, we used to count time. And then we use second as a base unit. And similarly here, current, when current is passed, then we have to use the unit ampere. And here k is when we have to deal with temperature, then the unit that we will take would be in Kelvin. And similarly, the number of the number of amount of substance, or the number of substance, would be count in mole. And similarly, the the intensity of any light is measured in candela. So these are the 7 base units, or I would say these are the 7 international units that is used in measurement of physical quantities, right? So as we know, these are the base units, or they are the base units which were derived in System of International, which were used in which were used in measurement of any physical quantity. And the remaining thing, like if I'm talking about the volume, as we know, the volume is the unit of volume is meter cube. As we can see, how can we simplify this? Meter into meter into meter. So here 3 meters are combined in order to get the meter cube, right? So the meter is the base unit, right? So meter, here 3 meters are base unit, and the derived unit from this base unit is known as derived unit. So the units which are derived from the base units are known as derived units. So here seven main important base units are this thing, that is second, meter, ampere, Kelvin, mole, candela, and kilogram, right? So we will talk about different physical quantities that would be useful in our study of chemistry. So here we will learn about some prefixes used in SI system. So different prefixes are used for different multiple. For example, 10 to the power 2 is known as hecto, 10 to the power 3 is known as kilo. Here let's count different numbers. 10 to the power 10 is known as deca, 10 to the power 2 is known as hecto, 10 to the power 3 is known as kilo, 10 to the power 6 is known as mega. Here see, if we record a video, then if we want to see the detail of that video, if I would say how much storage it covered in our storage, then then we will check the detail, right? So if we see a record video in megabyte, then we are dealing with the 10 to the power 6 unit, right? Here see, you can see 10 to the power 6 power, known as mega. And similarly, if the video is very long length, if long length video is recorded, then the storage that it would cover in total storage of our total internal storage that would be in gigabyte. So here I am dealing with 10 to the power 9, right? So it will be known as giga. Similarly, if we want to buy a storage material, or I would say external hard disk, then the if we search in Amazon or whatever, anything, retail shop, then they show storage in TB, right? So they will say 1 TB of hard disk, 2 TB of hard disk. Then here we have to notice that the 10 to the power 12 unit is known as tera. So if a shopkeeper is saying 1 TB of storage, then he is saying 1 terabyte of storage, right? Similarly, peta, hex, exa, jetta, and yotta are used. So what we have to notice here is the power. If we increase the power in positive way, then this unit are used, like dexa, yotta, kilo, mega, giga, tera, peta, exa, jetta, and yotta. If we are increasing the power in positive way, if we are increasing the power of base 10 in negative side, then it will be named as deci. 10 to the power minus 1 is deci, 10 to the power minus 2 is centi, 10 to the power minus 3 is milli, 10 to the power minus 6 is micro. If we are if some if any science teacher says we will learn about microbiology, then he want to say is he is he have to learn about the microorganisms, means the size of that living thing or non-living thing would be in 10 to the power minus 6 meter, 10 to the power minus 6 meter, micrometer. Micro is a unit prefixes used in system of international for 10 to the power minus 6. Similarly, nano, you have seen nanoparticles, the particle which that have 10 to the power minus 9 size, meter size, will be known as nano. Similarly, 10 to the power minus 12 is pico, 10 to the power minus 15 is femto, 10 to the power minus 18 is etto, jetto, and yotto. These are the prefixes used in center system of international, and these are useful units used by chemist for dealing with the different dealing with the different numerics. So after dealing with prefixes used in system of international ASI system, now let's measure the quantitative analysis of mass and weight. So so what is the difference between mass and weight, right? So if we want to define a mass, then it is a total number or amount of matter present in it will be known as mass. So mass is its amount of matter present in it. Amount of matter present in it will be known as mass, while if this mass has put on any gravitational surface, or I would say if the mass is attracted by gravity, then that mass will be termed as weight, right? So weight, when 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 mass is under the influence of gravity, then this will be weight. So if we are saying I am 60 kg, then we are saying mass along with the gravity associated with that particular mass, right? So what is here, the weight could be changed according to place. If our weight in if our weight in our earth is 60 kg, and if we go to moon, then the weight would be changed. The weight would be changed in moon, because the gravitational force in moon is lesser as compared to earth. Then if my weight is 60 kg in earth, then in moon that 60 kg would be reduced to 50 kg or 40 kg, right? So why? Because the gravitational force is lesser in moon, but the gravitational force in our earth is 9.8 meter per second. So weight is when when mass is under the influence of gravity, then it will be termed as weight. But if only the amount of matter present in it would be known as mass, right? Now let's talk about volume. So what is the volume? Volume is the amount of space occupied by a substance. If I say this particular matter has 5 liter of volume, then what I'm saying is that particular matter is occupying 5 liter of volume of the whole space, right? At that 5 liter at that particular 5 liter of volume, we cannot place any other volume at that particular place, because this place has been occupied by 5 liter of the matter, right? So how the volume is what is the volume of volume what is the unit of volume? So we say volume, unit of volume is meter cube, or length cube, right? So here the length of any particular matter, height of particular matter, and width of particular matter is taken under the study. So this will be known as volume. So here we see the volume. If we say volume, generally the length, SI unit of length is meter, right? So meter is a SI base unit. And if I am saying the volume, then the cube of that particular length is SI unit of length is meter, and the volume is length cube. Then the SI unit, derived unit will be meter cube. But this is a very high quantity, and in laboratory we have to deal with small quantities, right? So so this meter will be reduced to centimeter, or it will be reduced to decimeter cube, centimeter cube, right? So some of the measurement of volume, will be, I will write here. 1 liter is equal to 1000 milliliter, right? And 1 centimeter cube is equal to 1 ml. So what we see here is 1000 centimeter cube is equal to 1 liter, right? So, and 1000 centimeter is also known as 1 decimeter cube. So 1 decimeter cube means 1 liter of 1 liter of solution, or 1 liter of any matter, right? So let me explain you what I am saying. If I am saying a volume, let's suppose I am saying 1 centimeter cube. 1 centimeter cube of water means 1 ml of water. Okay, so what I am saying here is, if I am saying 1 centimeter cube means 1 centimeter of length, 1 centimeter of height and 1 centimeter of breadth. ठीक, 1 centimeter of breadth, and the volume occupied by this particular space will be 1 ml of solution, right? So 1 centimeter length and 1 centimeter breadth and 1 centimeter height of a particular any container that can only occupy 1 ml of liquid. So this is volume. And now we will see temperature. Now let's talk about the temperature. Is the system of international unit of temperature is Kelvin. So if we have to deal with any hotness of any substance or hotness of any matter, then the unit that we will take is Kelvin. Kelvin. And there are other different scales for measuring temperature, and they are Kelvin and Celsius, and another is Fahrenheit. So these three scales are used to measure the temperature of any matter, right? So generally the Celsius scale is from 0 degree Celsius to 100 degree Celsius, and here 0 degree Celsius is a freezing point and 100 degree Celsius is a boiling point of water. So if I want to change the Celsius unit to Fahrenheit unit, first of all you should know the scale, that is the scale from 0 degree as the scale is 0 degree to 100 degree Celsius in case of Celsius, but in case of Fahrenheit it is range from 32 degree Fahrenheit to 212 degree of Fahrenheit, right? So if I want to change the Fahrenheit to degree Celsius, then the formula that I will be taking is Fahrenheit is equal to 9/5 degree Celsius plus 32. Let's take an example. If I am saying what is 50 degrees Celsius, what is 50 degrees Celsius in Fahrenheit, then what we have to do is just put 50 degree in the equation, 9/5, and if I am saying 50 degree Celsius, then I am taking 50 here and plus 32, then what the value would be in Fahrenheit. So let's solve this. So the value will be 9, 10, 11, 122 degree Fahrenheit. So the 50 degrees Celsius would be 122 degree Fahrenheit. Similarly, the Kelvin scale is range from 273.15 to 373.15 Kelvin. So if we want to change Celsius to Kelvin or Kelvin to Celsius, then we will take the formula Kelvin is equal to degree Celsius plus 273.15. So we have to just put the degree Celsius value in this particular equation, then we will get the value in Kelvin. So these temperature scales are interrelated to each other. Okay, so now we will talk about the density.